Okay, so this one here, start to finish, see if you can come up with standard form, the value of p, the value of q, and then use this initial condition here to figure out what the constant is. Okay, so I hear some people using the right language in there. There is a constant that appears. So if you got a constant somewhere in your solution still, you're on the right track. But what's going to happen here is when I take my p of x, this time 2x minus 1, and q of x, which is 0, then I need an integrating factor. So it's going to be e to the 2x minus 1, which gives me e to the x squared minus x. So, so far, it's pretty straightforward, but I'll show you where the careless mistake comes in. Now when I set this up, and I get y equals 1 over the integrating factor, q of x, which is 0, times 2x minus 1. Well, what that means is 0 knocks this out, the whole thing becomes a 0, and I end up with 1 over e to the x squared minus x times the integral of 0 dx. And that's the part that people kind of think, oh, well, I'm multiplying by 0, the whole thing must disappear. But that's not what's happened. This says that you're integrating something whose derivative is 0. So what has a derivative of 0? A constant, right. So that's what I have to include here. That was missing before. It's going to be 1 over e to the x squared minus x times a constant. Okay, so the derivative of a constant is 0. So that's how I know they match up. So we need to use the initial condition, which says y of 1 equals 2. So I'm going to put that value into my general solution and find out what the particular one is. So this means that 2 equals c over e to the 1 minus 1. So that tells me that c must equal to 2. So the constant in the original example would have been 2, and I would have an answer for this particular solution as 2 over e to the x squared minus x.